So, hi everybody, I'm Ryan Sayer. I'm a storage specialist. I cover Elastic Block Store, but I get to see lots of other things. I have a background in storage, both as a user, as well as some of the on-prem vendors that you might have heard of. Jim.
And good morning, my name is Jim White. I also, like Ryan, have a background, first of all, as a customer. And then I worked at a couple of other storage vendors, namely EMC and NetApp for a period of time. And so I've been at AWS now for about 4 years and had the opportunity to launch one of the services we'll be talking about today.
The context that we're going to be talking to you is really about self-managed storage. Self-managed storage factors in a lot of things to think about. Your organizations really are moving databases in general to AWS at a lightning speed. In fact, and you understand already, being here at reInvent, you understand the notions of being able to reduce costs, be able to innovate quickly because you're in the cloud, and really be able to focus on the applications that you're building within your organization for success. So when we think about database, we really think about choice. And this is a slide you might have, how many of you have heard of database freedom? Okay, some of you. The idea of being able to choose all sorts of different services, whether it be focused on a managed solution or a self-managed solution. And that's really what database freedom is all about, is being able to get the best of what is offered to you within AWS. I really like this slide because it also allows kind of this mechanism, the hooks, potentially into future applications. You could add in components of generative AI into your databases or your analytics, or the mix of both. And I really like that broad, deep portfolio that we offer. If we had to think about self-managed databases, however, because maybe you don't necessarily want a managed offering, there's good reasons to have that. So how many of you are actually self-managing in the cloud today? Okay, so a good number. So you already understand the need for control, for example. You might have some databases in RDS where you've deployed, everything's good, but perhaps there's a compliance requirement, or perhaps there are stored procedures that RDS is not appropriate to, or maybe you have certain database user requirements that are very specific to your organization. So that flexibility, being able to have the infrastructure available to you with AWS, means that self-managed databases actually works really well. These are some of the databases that people are deploying. Now, when you look at these databases today, you think of those as kind of more traditional or kind of scale-up or enterprise. If you think about other databases that are also coming into play, you might start thinking about like a CockroachDB, a TinyDB, a MongoDB as well, which sometimes breaks the model a little bit of the classic DBA architecture, but the self-managed themes still very much apply. So if you're using these, you have lots of good footprint, as well as examples for well-architected code and being able to deploy into EC2 or on containerized using ECS or EKS. And frequently that pops into using EBS and FSX for block and file. Now, when we're thinking about deploying our databases onto AWS, we're many times thinking, okay, maybe I have an operating system where my database works best in, or I have a legacy requirement that I have an expectation for a particular processor type, or I want to integrate into a specific workflow that makes most sense to me. You can be able to build that within AWS, self-managed, that very much mirrors the architecture that you've already deployed already. So that means that if you just are in a factor of, hey, I want to lift and shift into AWS to get access to all the other good things that AWS has to offer, and potentially add in cloud analytics or mechanisms into data lakes, you have that ability. And that's quite a powerful mechanism of why you want to move your compute. But you also want to think about how that database performs, which factors into the storage component of that. How many of you deploy exclusively on block storage for your database? So good number of you, and some of you are block and file as well. I would imagine the rest of you are. You can be able to choose and mix and match as you need. I come from on the EBS side, so I'm a little bit of a blockhead biased person, but you can be able to choose and be able to dial up, dial down your performance as you need. If you have a specific expectation for your RTO and RPO, keeping everything online, then you're going to want to architect in a certain way, integrating in snapshots, replication, or application managed resiliency. Focusing on agility, we can always talk about the security of the cloud, the resiliency of the cloud, as well as being able to spread that application across multiple AZs, multiple regions. But ultimately, also, it goes down to TCO. If you know your database very well, you're intimately aware of how it affects the business, and that you have the absolute control of that, being able to self-manage really drives that TCO because you know your database better than anyone else does. So factoring into the storage portfolio, you have lots of different options. And very interestingly enough, we're a little bit biased today in talking about block and file for the solutions, but there are solutions that are using S3 and using object access for their database. That might be for backup, that might be for a data warehouse component, that might also be, you might have another component that factors that in. But we're going to be focusing really on what translates very easily into AWS, which is block and file. And with that in mind, with the nuances of file, there's also FSxN, which also can do block. So it gets to be a little more nuanced than we have on the slide here today. And with that.
Thanks, Ryan. So again, our point today really is to address these 4 services that you see outlined. So we'll talk about Amazon EBS. We'll talk about 3 members of the FSx family. As Ryan pointed out, really one of the design goals of the FSx family was to bring popular commercial file systems that are well deployed and well adopted on premise to AWS. Thus, we have FSx for NetApp ONTAP, FSx for Windows File Server, FSx for OpenZFS, and FSx for Lustre. Now, Luster's not really in scope today for our conversation. We don't tend to see that deployed for databases. So we'll focus on EBS and then these 3 FSx services. And again, the reason why we wanted to draw some attention to these 4 was because these are the ones that provide the features and capabilities that most closely align with what database administrators and infrastructure managers want to have underlying as part of their infrastructure stack for their databases. And as Ryan mentioned, generally speaking, the FSx family was designed to provide file access, the one exception being ONTAP, which natively provides file and block, so we'll get into that in a little bit. And then EBS, of course, is a high-performance block solution. As we think about kind of the superpowers of these services, they're all designed to do different things. They all have capabilities and features that, for the most part, are unique, which I like to refer to as their superpowers. But if we start on the left-hand side of the slide here and kind of work our way right, starting with EBS, that's going to provide, as we mentioned, a block connection, a block experience. It's a very simple to deploy offering, and it's going to provide more than likely the highest performance experience in the portfolio here. As we move across the slide, we've got ONTAP and ZFS, both of which provide a rich set of features and capabilities that customers, if you've run ONTAP or ZFS, or you've experienced at any point in your career, you know that they do many interesting things that a lot of other storage services don't do. And so we categorize that as kind of a rich data management capability. And then lastly, as you look across the FSx family, as I alluded to earlier, the reason we brought those services to AWS was to provide a familiar experience. So familiarity can be quite important for customers bringing workloads to AWS. I want to learn as little new as possible. I'd like to have a similar experience to what I enjoyed on-prem. As I move to AWS, that way I don't have to retool, retrain, relearn. And thus we have those 3 services. So familiarity is key. Also, when you look at the FSx family, we provide by design either a multi-AZ HA or a single AZ HA deployment type, which means that it's highly available by default, but when you build it across AZs, you actually get some additional built-in capability, which I'll talk about in a later slide. So if you look over on the far right-hand side, these are some of the things that we think customers want to think about. They want to think about which features and capabilities do I need storage to provide? Is familiarity important to me if I'm coming from some other storage solution, on-prem or otherwise? And then how do I want to match those features and capabilities to my business? Okay, Ryan, back to you.
Yeah, so all of you are deploying EC2, so you're also using EBS because that is the fundamental storage that powers EC2 and many of the other managed services as well. When we think of the categorization, the main categorization of volumes available, there are more volumes that you can provision if you want, but these are like the main volumes that I see deployed for database applications. If you don't know what your requirements are for your database in terms of performance, be it bandwidth or IOPS, GP3 is really the general purpose SSD that is by default, that is the default SSD EBS volume type when you're provisioning something like Amazon Linux 2023. But if you are mindful to deploy with a focus on lower latency, like a very small latency, or you want to provision a lot of IOPS and a lot of bandwidth for your application, that's where IO2 Block Express comes into play. So different reasons to deploy. I'll get into some of the other extra advantages of IO2 Block Express in another slide. But don't call out HDD. HDD is really worthwhile because many of the database operations that we have are batch operations. And they're also in test and dev environments where we don't necessarily really care for a latency requirement. That's where ST1 comes into play. We can do a lot of good enough types of deployments on ST1 that are not production, that don't have another person either swiping a credit card or interacting with a live website, where ST1 really does the job very well. And finally, SC1, if you have logs that you want to dump to another volume, and maybe this is application owned, maybe you have a third-party utility, or maybe you're manually doing it, SC1, Sierra Charlie 1, is the lowest price block volume that's available that you can just dump that out, and it's there. You may also have some applications that you just have to keep online for occasional use. SC1 could be a good solution to that because it is online. So if you needed to reference that database set, but it's very rare and it's not time critical, SC1 comes into play. So I quite like that. And I see so much of this when I'm talking to customers that are using databases. Now, when we go into the deep details, and I don't want to bore you with too much information, but I think it's good to call out durability. You'll see that it's generally 3 nines of durability for the volumes that are out there. So factor that in as you have maybe hundreds of volumes, factor that in for durability and availability. But if you have a workload that is critically important as well as latency sensitive, that's where IO2 Block Express comes into play. They have 5 nines of durability. And so with that 5 nines of durability, you also get multi-attach. That's multi-attach both for Windows and Linux. So if you need to, or if you want to run a workload that has multiple EC2 instances looking at the storage, and either for an application region or a reason, or you have a failover event, one reason where you want to take that over, IO2 Block Express is really that sweet spot right in there. And I quite like it. And of course, that's for active workloads. Snapshot management, it can be used for replication, it can be used for backup. But if you have a requirement to keep a certain level of snapshots within a working period, as well as a need to have snapshots available for rollback, either for compliance or operational reasons, you can use the APIs and you can create a cron tab and build that behind the scenes, but that might create snapshot sprawl. So I recommend Amazon Data Lifecycle Manager. It's a no-cost solution to be able to orchestrate and manage these snapshots. So if you're already doing that, be aware that Amazon Lifecycle Manager also has pre and post hooks into the applications. So you can be able to quiesce the database and be able to make sure that everything is all peachy keen in terms of when you're making your snapshots. So I really like DLM, Amazon Data Lifecycle Manager, to be able to manage that. If you also want to deploy your AMI management, I think that DLM can be able to manage that across multiple regions. Now, going back to the active data use case, I love elastic volumes. How many of you have actually used elastic volumes, moving from like GP2 to GP3 or anything like that? Okay, this is great. This is, I wish that I could probably present a whole day on EV. It is the ability to be able to move from one volume type to another. So if you have a seasonal data set that maybe in the summer, it doesn't matter. Today is December 1st, it's Monday, it's Cyber Monday, so possibly you actually have a quite important, quite intense need for your storage. You could elastic volumes modify it to IO2 Block Express. Your really hot period, you're churning through those IOPS, you're serving those tables, and all the customers are super happy. Once that stressful period has gone down, you can just EV move it back to GB3, or if you know that it's not even going to be seasonally it's way out of season, but you want to keep it online, you can just set it out to pasture with ST1 or SC1. So really cool stuff. This is online. You get your weekends back. So you can do this while your application is running. And many customers, they'll be really skeptical and they're like, well, we think that there's going to be downtime. There's no downtime with this. So that's why I say you get your weekends back, because you have your performance that you've committed and paid for, and you're able to upgrade or downgrade as you need. So online use, love EV. It's you don't pay to use elastic volumes modifications. It's just built into the volume system. And Fast Snapshot Restore. Fast Snapshot Restore is a mechanism in which you can be able to keep your volumes really on hot standby for very fast rehydration from those snapshots. Some users actually use FSR for very tight RTO, RPO, and so they'll actually keep it running on the waiting. But many times what I see a lot of users use FSR for is when there's a time to upgrade a database version, or maybe you're converting from x86 to Graviton, and you have a lot of many things moving at the same time. Keep FSR running, and so if there is a need to, let's say for some reason, upgrade didn't work, we need to roll back, you use FSR to be able to restore, and it's a quite simple and clean and efficient way of being able to deploy that. I could go on forever for elastic volumes, growing volumes. Please check that out if you get the chance, because you will be able to do some very interesting creative things with that. And then finally, being able to map like which databases, and again, databases is so unique to the organizations that are out there, but being able to just kind of stereotype what databases that I see landing on which volumes. GP3, it's the sandwich that everyone loves to eat, continues to eat it, keep eating it, it tastes good. If someone wants a very tasty, very intense sandwich to eat, for your most critical databases, IO2 Block Express is very good. Also has mechanisms like that multi-attach feature and 5 nines of durability. And then again, batch, log files, really kind of the chill databases that you keep online, but they're not so intensively demanded upon. That's where the HDD volumes come into play. So ST1, SC1, quite like it. And I love this. So do any of you know about SRD? No? Okay, so there were whole tech talks maybe a couple years ago getting into SRD, which is really a new protocol that we have come up with, inspired from the HPC team, where we have created a level of multipathing as well as bandwidth sharing across our whole infrastructure to be able to deliver those sub-millisecond latencies that you would expect to have on premises. I love SRD. I could go into it quite significantly, but we don't have time for that. But SRD, when you think of multipathing as a classic SAN-based database administrator, you can kind of think of that as mapping into the Amazon world that way. And yeah, the ability to deliver SRD with improved latency times, improved throughput, improved consistency, that is so significant. So are any of you on IO1 today? Okay, a few of you. You can use elastic volumes and just EV modify your IO1 volumes without any downtime to IO2, and you will benefit from this. So I've been really happy with giving users a treat. And there's no price difference between IO1 and IO2. In fact, if you're a high IOPS user, you'll get an effective discount moving to IO2. So you might be at multiple advantages moving to IO2. So something to think about. Our users really love it. Why would you choose that? Why would you choose EBS? So we're talking about different services. And really, if you have a compute-centric mindset or an application focus where you're thinking about deploying storage, but you might have different dimensions of storage that you're accessing, EBS is great. And in fact, that it means that you can still maintain and preserve those application-centric features that are managing resiliency, that are managing replication, that are managing availability across multiple AZs, multiple regions. This should feel very natural to you. But if you want to integrate in some of the data protection, which I absolutely recommend, use DLM and take advantage of pre and post hooks. And our customers have absolutely taken advantage of it in terms of the deployment. So moving to IO2 Block Express from on-premises felt very natural, and they were able to accelerate their resiliency and recovery mechanisms. In terms of Marqeta, they were a MySQL user, and they were able to use their application-centric resiliency model to go multi-region. So definitely is a performance improvement. Definitely their ability to deploy very quickly is fully enabled with IO2 Block Express. And with that, I'll hand it over to Jim.
Thanks, Ryan. As we segue now to talk about some members of the FSx family, I want to draw your attention to really how we think about positioning these and how we think you should think about adopting them. So starting on the left-hand side with FSx for Windows, obviously that's built on Windows infrastructure. And so for those customers that have an entire Windows-based stack, it makes perfect sense. Obviously I'm running SQL Server on a Windows server. I might like to provide that same storage experience I had on-prem with Windows, or I might decide that because I'm only comfortable running Windows in my stack, that FSx for Windows is the perfect solution for me. And so we will see customers deploy SQL Server in its various variants on FSx for Windows file server. For those of you who haven't seen it before, it's very easy to deploy, a few mouse clicks. It looks and feels and behaves like Windows in terms of its administration capabilities, and it brings all those same features that you may be accustomed to on-prem if you're running Windows to the FSx family. As we look at FSx for OpenZFS, again, you may have familiarity with ZFS over the years. It's a fairly rich feature set that comes along with ZFS, things like snapshots and clones and built-in replication. Those things tend to be quite important for many database administrators as they think about how to protect their data, how to create copies of those databases very quickly and at a low TCO. So we tend to see OpenZFS chosen for Oracle databases, PostgreSQL databases, for example. Those tend to be kind of the sweet spot that we see. Now this is an NFS connection, so with FSx for Windows, of course, that would be an SMB connection, what we used to call CIFS in the old days. NFS for FSx for OpenZFS. As we segue over to ONTAP, that provides either block or file connections of various flavors. So on the file side, it supports both SMB and NFS, as you may know. On the block side, it supports iSCSI, and it also supports, more recently, NVMe over TCP. So we have some customers running database that are very adamant about, I have to have a block connection for my database. Well, that's either EBS or it's FSx for ONTAP. Those are your two choices. If file is a possibility, and then we need to drill down to the protocol. If it's SMB, that's either Windows or ONTAP, or if it's NFS, that's either OpenZFS or ONTAP. So lots of variety here, which can sometimes create confusion because it leads to the question of, okay, I don't know which one to choose. What should I do next? So let's talk about that. First of all, before we do that, I want to talk about a couple of features, and I think these are kind of table stakes for which one should I choose. As it turns out, with the entire FSx family, at least those services we're talking about today, you have the ability to choose either a single AZ deployment or a multi-AZ deployment. In either case, it's an HA deployment. So what we're depicting here, as you can see over on the left-hand side, upper left, is these services are built on a two-node infrastructure, an active node, a standby node with shared disk between them. There's actually a couple of copies of that disk, so you shouldn't be concerned about a drive failing or something of that nature causing a challenge or an outage. But the idea is if that active node fails, it fails over to its standby, there's no data loss, it happens very, very quickly. The application or the database won't sense it. There may be a slight pause in I/O during that period of time, but there's no application outage. As we move over to the right-hand side, that's a multi-AZ deployment where we literally take that deployment and we stretch it across 2 AZs, and we implement synchronous replication at the storage service level underneath the covers. So I now have a full copy in AZ1, I have a full copy in AZ2. So if that failover event occurs, my hosts, my EC2 hosts running databases are pointed at that active node in AZ1. If that goes away or becomes inaccessible, a failover occurs up at the host cluster level, in which case they address the second copy of the data, which again has been synchronously mirrored, so there's no data loss, there's no impact to the production application. So interesting way to do this. There is a cost difference, as you might imagine, between these two. It costs more to deploy over 2 AZs than it does in a single AZ, so that's something that customers often think about is this resiliency model sufficient? Do I need something that probably provides a little bit higher durability in certain circumstances and comes at a higher cost? What we also sometimes see is customers will deploy 2 single AZ, region 1, region 2, and then they'll do database-based replication or application-based replication between the two to provide that higher resiliency experience that they're after. Okay, now I want to drill down into sort of the secret sauce of these storage services and really where they begin to add value or could potentially add value in your infrastructure. I want to start with snapshots. These snapshots are so fundamental in the storage industry that I think everybody knows what they are. The way that they're deployed is slightly different depending upon the storage service in question. In the case of both FSX for ONTAP and FSX for OpenZFS, essentially you have a volume, and in that volume you have a portion dedicated to active data, and you have another portion of the volume dedicated to manage and store snapshots. Snapshots in and of themselves are thin. They don't occupy any space whatsoever. You can take multiple of them on a given day. We have some customers that take them, for example, every 4 hours, every 1 hour. We have some customers taking them as often as every 15 minutes. But what's really, really interesting about this is using a software shim installed on the EC2 host where the database is running. These can be application and database consistent. So in a database scenario, let's say I've got a SQL Server or an Oracle or maybe an SAP HANA or any of those other databases that Ryan showed earlier running on that EC2 instance or set of instances. What I can do is using this software, which has the ability to call the database and say, thaw yourself for a second. I'm going to take a snapshot. Take the snapshot. Now it calls the database and says, freeze yourself for a second, take the snapshot, and then thaw yourself. That all happens in a matter of seconds. But what it guarantees is that that snapshot is database consistent. And when one goes to recover that database, there doesn't need to be any roll forward recovery per se as a result of recovering from a snapshot. It simply puts it back to the point in time when the snapshot was taken. It takes a matter of minutes. By the way, snapshots can be taken in seconds, and rolling back a snapshot and recovering from that previous point in time when that snapshot was taken takes a matter of minutes typically. It's very, very fast. So the idea is I want to make sure I have as many recovery points as my business needs. And perhaps most importantly, when I take these snapshots, other than them being database consistent so that they're obviously usable, I don't want to create a performance impact in the act of taking a snapshot. I don't want my production database to be impacted at all by the fact I'm taking this snapshot. So that's in fact the way these work. You can of course replicate them from one file system to another using underlying FSX technology. So I have a database in region 1, I take snapshots, I might want to replicate those snapshots to region 2 to another FSX file system for purposes of disaster recovery. Now something really interesting that can be done based on those snapshots, this is the same snapshot model you saw before, I can now create what's called a clone using those snapshots. So I've got 3 different snapshots represented on this slide taken at 3 different points in time. I can clone each of those snapshots and now I have 3 distinct virtual copies of that database at 3 different points in time. So what I can begin to do with these clones is things like refresh my development and test environment more often, not have to come in on a weekend or administer a copy process over the weekend. I can simply at 2 o'clock in the afternoon on a Tuesday, I can take a snapshot, I can clone it, I can bring up a development database, a test database, a training database because I have a class tomorrow. Any of those options are possible. And what's really cool is because a snapshot doesn't take any space, I build a clone on top of it, which is a virtual full copy of that volume represented by that snapshot. They don't take any space either. So the only impact associated with adding space in a clone environment is if I add data to that clone. So a clone is read-writable. I want to make sure that that's understood. I might take a copy of a database in the form of a snapshot at 10 a.m. this morning. I might clone it at 10:30 using that 10 a.m. snapshot. I can now start to add tables, delete tables, whatever I decide to do to that clone copy of the database. It's now diverged from the production copy of the database, of course, and it effectively is its own instance of the database that I can do whatever I want with. I can test an upgrade of Oracle. I can test dropping tables, adding tables. I can test all kinds of what-if scenarios using those clones. And when I decide I'm done with them, I tear them down. So they're very easy to create, they're very easy to tear down. The idea is, what could you do if you had more copies of your database? How much more could you test? How much more agile could you be? How much faster could you move if you could make more copies of your database? This is the answer to that question for many of our customers, is to use clones. Now, one last thing that's interesting here, it's represented by that last bullet on the far right, which is if and when I decide to split a clone from its parent, so these clones are tied to this parent unless and until I split them. When I split them, if I split them, when I split them, basically that causes a full copy to begin to occur, okay? So now I take all of that active data at the point in time when that snapshot was taken, and I copy it to clone number 1, for example. And now I can split that off, and I can actually promote that to production or to be my lead development copy. Sometimes we see customers do this between regions where they will take these clones, they will then replicate from region 1 to region 2, they will promote a clone copy, and they will start up a production application pointed at that clone copy on the other end in that other region. It's a really, really cool way to do a disaster recovery test. And again, you can do it at 2 o'clock on a Tuesday if you decide to do so. If somebody says to you, prove to me that you can start up an application in another region, and you have a couple of hours to do that, really, really easy to do. I have my Flex clone. I basically can either split that or keep it attached to the parent volume. I can start up another instance of a database pointed at the tables, the logs, etc., represented by those clones. I have to do a little bit of massaging, of course, at work, up front to make sure that I have a different database name. If it's Oracle, I have a different SID, etc. So some of that work needs to be done up front to make sure that both databases can be running at the same time. But very, very simple way to do this, and we have a ton of customers doing this. Very, very valid feature. In fact, it's been used on-prem with ONTAP and ZFS for decades. So let's talk about a couple customer examples here. I think everybody knows who Adidas is. They I want to say about 18 months ago, they came to us and they said, we've got a number of ERP systems spread out all over the place in multiple data centers and multiple pockets. We want to consolidate all of them. This was all on-prem, by the way. We want to consolidate all of these instances into a single set of instances. And oh, by the way, we want to upgrade from SAP's ECC, which is legacy ERP, to S/4HANA, which is modern and current. And so they actually assumed quite a bit of risk. They were like, let's move from on-prem to the cloud. Let's change the underlying databases, and let's completely change our processes around management of this entire infrastructure stack. So really, they kind of went out on a limb in doing this, but it's worked out quite well for them. This is one of the largest S/4HANA implementations in the world. It's all on AWS. And they chose, for this particular deployment, FSx for ONTAP for the reasons we just talked about. Snapshots and clones. They had a recovery and restart problem, not so much a recovery problem per se. The recovery problem took lots of time. but their goal was, so let me just say it this way. It's one thing to recover the database, it's another thing to restart it. In the case of HANA, it's an in-memory database, so the entire database has to be loaded in memory before it's restarted. And so they were concerned about the time it takes to recover and restart. As it turns out, it was taking them as much as 4 hours previously on-prem to recover their entire ERP instance. They now say it takes less than 20 minutes in AWS because they're recovering from the snapshots, like I talked about earlier. They're also utilizing flex clones to populate their, which is the name of the clone feature in ONTAP, to effectively create copies of their databases. So development, test, training, and they have a whole other sandbox they're using for some upgrade type scenarios. They're doing all that with snapshots and clones. So they're extremely happy, and as you can see, their recovery time went down about 59%. One other customer I want to talk about here, this customer is Amdocs. They're in the financial services space, they're in the telecommunications space, Amdocs is, they are basically in the business of, for their own internal, the way they run the business, they have multiple databases per customer. So you can think about large telecommunications and other communications companies. Amdocs caters to them. In many cases, they have multiple databases associated with each of their customers in their infrastructure. So they looked at a couple different storage services in AWS. They chose FSx for OpenZFS. Completely comfortable with an NFS connection to their Oracle databases. This is an Oracle workload, by the way. And so they're literally creating, as that second bullet on the upper right says, hundreds of standby databases, reporting databases, and test and development databases, again, using snapshots and clones. As we think about something that often comes up, it's not only resiliency, which we addressed a little earlier, but also performance. And so we sometimes get asked, how do these services perform against one another? And all the testing we've done, corroborated by our customers, indicates that FSx for OpenZFS provides the lowest possible latency across these three FSx storage services we're talking about today, not only in database environments, but other high-performance environments. So very successful deployment on the part of Amdocs of OpenZFS. Couple last things that I want to address. First of all, how do I migrate to Amazon FSx? And first and foremost, that depends what you're coming from, right? For example, if you're coming from ONTAP or OpenZFS on-prem, they both have replication engines on board. You can simply replicate that data. In the case of any other storage, whatever it might be, there are a variety of ways to get data from that storage to FSx over there on the right-hand side. Things like AWS Data Sync, if you're migrating files. Again, if you're comfortable with running databases over SMB or NFS, you can use Data Sync to move those files, copy those files, I should say, from A to B. There's a host of ISV tools, things like Cirrus Data or River Meadow, who have long since been in the industry. They've focused on block-based migration. So if I'm migrating from a database hosted on block on-prem and I want to come to EBS or I want to come to FSx for ONTAP, both Cirrus Data and River Meadow do that quite well. And then lastly, there is, of course, database-based replication, which of course is still quite common. I've got my database stood up here, I've got my database stood up over there. I'm going to replicate between those two database instances to migrate the data. I've called this a couple times, but this also applies for OpenZFS. It's not shown on the slide, but the idea would be if the storage service has the capability to replicate between itself or as a native feature, then that's what we advocate for. In the case of ONTAP, it supports something called SnapMirror. So not only, if I go back, is it the migration tool from NetApp on-prem to FSx, it's also the data protection tool between regions or between on-prem and AWS. Sometimes we have customers that want to leave their databases on-prem, but they want a DR copy in the cloud. And so in the case of ONTAP to ONTAP, SnapMirror does a tremendous job of that. All right, one last customer case. Actually, I think I have one other beyond this one. This is S&P Global. Many of you probably know who they are. They're in the financial services segment, and they wanted to bring a bunch of SQL Server instances to AWS. Specifically, they deployed SQL Server FCI, failover cluster instances. They did this for two reasons. They wanted to remove the additional licensing cost associated with Microsoft Enterprise licensing, and they saved a pretty good bundle in so doing. But they also wanted a multi-AZ storage deployment in AWS. So if I go to, I'll come back to this in a second, but if I go to this slide, this is effectively their infrastructure. So two AZs in the same region. I've got my SQL Server deployment spanning those regions, one node on either end in clustered form. I've got FSX for NetApp ONTAP in this particular case, and that's spanning those AZs. So I've got that synchronous replication going on between the two. And in deploying this, they felt very good about it not only being highly resilient, but also considerably lower cost than what they were doing on-prem because their Microsoft licensing came down considerably. So that's what S&P Global is doing. They've got several hundred databases. They're using iSCSI as their connectivity method. If I roll forward now to Change Healthcare, they're doing the exact same thing, but this is with FSX for Windows. The protocol here is SMB, of course, spread across those two AZs. And their design goal was to bring, again, several hundred databases to AWS. Same exact set of requirements. They wanted to lower their licensing cost. They wanted to make sure they had a good performance experience. And they also wanted to be able to have that resiliency associated with a cross-AZ deployment. In this particular case, they are nearly a 100% Windows shop. So for them, FSX for Windows was the natural choice. All right, this is a bit of an eye chart, I know. I'm not going to spend a ton of time on it, but the intent here is to compare these three FSX services to one another. And you look at the feature set on the left-hand side here. These are the features associated with these particular storage services, and the business value that offered by that feature is indicated on the right-hand side. So I'll just call on a couple. If I look at, we talked about this earlier, if I look at creating database consistent backups, that's not something that FSX for Windows can do natively, but in the case of ZFS and ONTAP, that can be done through that snapshot mechanism I described earlier in a matter of seconds, and associated recoveries in a matter of minutes. So the idea here is, what is your set of requirements? What are you trying to do? What are you coming from on-prem or perhaps from some other cloud? And how can we most closely and carefully match that in terms of choosing one of these services, whether it's one of these three FSX services or whether it's EBS, as Ryan spoke about. Okay, so you saw this slide earlier for EBS. I'm going to summarize here with, why should I choose FSX? It might be that I'm looking for a familiar experience because I'm coming from either ONTAP or ZFS or Windows on-prem. Again, I want to have that same experience in AWS. I might want blocker file access, right? You can get both or either with the FSX family. Storage resiliency is often important. Generally speaking, performance and resiliency go hand in hand for database administrators. So the idea is that multi-AZ deployment right for me? Yes or no? If so, you can get that with FSX. And then lastly, some of these features I've spoken about, snapshots, clones, replication, all of which are on board. One thing I haven't mentioned is, which was a factor in a couple of these customer stories, is the ability to apply storage efficiencies, which are native to the FSX family, either compression or dedupe. In fact, if I go back to this last slide, that last line represents storage efficiencies. You can see there's some variation of dedupe and compression or dedupe and compression associated with these services. Now, we don't always see strong results associated with dedupe with databases. We might, but oftentimes we do see really good compression results, could be 40, 50, 60% associated with compression of a database. So while not all customers turn those features on, it's a toggle, you can turn them on or off. We do find that they can add significant value in terms of reducing the overall TCO. Okay, lastly, where do I get started? My recommendation usually is to work with your AWS account team to do some sort of assessment. It could be extremely formal, it could be rather informal, that's really up to you and your account team and what you decide to do. But oftentimes there are things going on in the infrastructure that are not always apparent. I know we all as infrastructure providers try to have an understanding of exactly what's going on in every pocket of our infrastructure. Sometimes that's hard. So an assessment can shed some light on those areas where we're not exactly sure where the data is, who owns it, how it's interrelated to other data in the environment. So an assessment can help shed light on all of that. These can be delivered by either an AWS resource or set of resources, or one of our consulting partners can also deliver an assessment. The idea is we tend to run data collection for roughly 30 days, could be longer, depending upon your given scenario. But what we produce at the end of the assessment is, hey, here's what we found. Here's how these databases or other workloads are interacted. If we were to build move groups to think about migrating them to AWS, here's how they group together and how they're interrelated. Here's how one performs relative to the other. Here's your development environment, here's your production environment, et cetera, et cetera. All those things can be discovered during the course of an assessment. So with that, we wanted to call your attention to one other thing, and that's this slide. It might be a little hard to read, I understand that, but we wanted to show how, from an overall presentation and session perspective this week, how richly storage is represented. Okay, these are all storage-related sessions. Some of them are focused on database as well. Not all of them are, but the idea would be if you're here to kind of be on a storage track per se, we have lots of options for you. So some of these may be interesting to you. They're of course all in the catalog, and you can find them there. So we've got things going on each and every day. So with that, Ryan, have you got anything you'd like to add?
Yeah, right in the middle, Tuesday, I am doing STG345. It's a funky one. It's actually mixed. How many of you use EC2 Instance Store for TempDB? Okay, this is a Chalk Talk. It's Linux-centric, but we can talk about Windows if you want to ask. But it's really merging in a lot of the best of EC2 Instance Store and EBS. So if you like experimenting a little bit to take advantage of your self-managed database, that would be a really good one. And you get to hear me talk again and do a demo. This is not all of the storage talks that are out there. There are lots more in the catalogs. We recommend that you go and pour through some really great demos that are out there. And with that in mind, we wish you a wonderful time at reInvent. If you have questions or embarrassing thoughts or comments, feel free to come to us and quietly engage, and we'll happily help. Thanks.
Thank you very much.